Okay, so hello,
Hello.
everyone. I'm Adam Goździewski,
I'm Axel Starosta.
and today we're going to present you how to forecast a future using ServiceNow tools and also a Python model, but more on that later. So first of all, small presentation of us. As I said, Adam Goździewski, ServiceNow developer and consultant.
Axel Starosta, part of maintenance and development team.
And what is the most important, we are the SME here in Spock. Our major topic of interest are like different machine learning things that can be used inside of a service now, like predictive intelligence or natural language understanding models, virtual agents, and so on and so forth. Goal of our presentation is to compare 3 different approaches to forecast the future using performance analytics, predictive intelligence, and time series. What we wanted to predict is the volume of incidents using the historical data, of course. Before we're going to explain you how we achieve that, we need to present you, define 4 different concepts, 2 strictly related to the service now. What is a performance analytics, the predictive intelligence. They are those 2 plugins in ServiceNow related to forecasting, analyzing data, and 2 things outside of the ServiceNow domain, the time series and data seasonality. So performance analytics is a ServiceNow plugin pretty much that can be used to present you data that you have collected inside of your ServiceNow instance. It's a great tool to show you the trends, the analysis, to make some basic analysis of your data. For example, here you can see the time series. Also here is kind of a trend analysis that performance analytics can achieve quite easily. More on that later, where Axel gonna to just show you how to do this and how to visualize such information. Predictive intelligence, pretty much the goal to show in our presentation what is the predictive intelligence and how to use it and how we configure it to let's say forecast the future amount of incidents. But the predictive intelligence, it's not only for forecasting the incidents, it's pretty much 4 different type of artificial intelligence solution that you can use pretty much outside of the box on your instance. What is also important is that the predictive intelligence is equipped with a natural language understanding API that can quite easily, basing on those languages that are shown here, extract the information from your text data, like a description of an incident, and then pass this data inside to your model. So pretty much you don't need to use like a digit data. Pretty much you can also use the natural text and using the NLU models extract some data and pass it inside to your predictive intelligence models. As I said, 4 different frameworks inside of a predictive intelligence are right out of the box, given the classification, similarity, clustering, and regression. Classification can allow you to easily, of course, classify your, for example, new incident record, again, basing on the historical data. And let's assume that you wanted to find the category of your incident basing on the, for example, short description may be a color. So using the historical data, classification gonna be able to classify your newly appear incidents to some category that you have already defined on your instance.
So in other words, it would be good to use it when we want to automate the creation of tickets and we have a lot of reference fields that are mandatory to submit the ticket. And I think that it can help you to automate the process and make it more easy and quick.
Yeah, especially quick. It's form of automatization. The new incidents appear in your instance, and the predictive intelligence classification can pretty much automatically assign this incident to the correct person. So that was the classification framework. The similarity. Similarity allows you to find a similar, let's say, records, tickets, to one that you are interested in. So, for example, let's say that you have the, again, best example, the incidents, and you wanted to analyze if there are any similar to these incidents that appear in the past. For example, to find a solution that was helpful in the previous states to solve the new incident easily. The clustering, it's like grouping different types of record to some cluster groups. For example, you can imagine that you have 2 different groups of your incidents, let's say, again, the normal incidents and the major incidents, and using the clustering methods, you can easily analyze them and maybe find the major problem that might cause those critical incidents.
So what's worth mentioning is that the training of models is happening automatically. So the clustering would happen, let's say, once a week, the training of the model. So when the new group of similar incidents come to our instance, we will be able to easily identify the major incident.
Yep.
And act on it.
Exactly. And the last one is the regression, the model that we used in our solution. Regression is like analyzing the data, usually basing on some numeric outputs. But as I said when I was talking about the NLU, not only numerical. You can, sorry for that. You can easily use also the fields like a description, short description, and so on to get this data, pass it into your model, and then predict some kind of values. We will talk much more about the regression models after a couple of minutes, as we use the regression model to forecast the future value of the incidents. Okay, so we talked about 2 ServiceNow plugins. Now it's time for 2 concepts that are not pretty much ServiceNow related. They are much more general concept. The time series. It's quite easy to imagine. The time series are just a data collected over some time period, usually time period. It is not required, but as the name suggests, usually it is over the time domain. So you have some samples of your data across the time domain, and they are usually presented by on a graph like this one, where you have on the x-axis the time domain, and on the y-axis some values. Here you can see the stock price of a Tesla from a couple days ago. So that was the time series. And data seasonality, again, you need to have some time series to talk about data seasonality. Seasonality is like a characteristic of your data when you can say that there is some periodicity inside of your data. Usually when we talk about seasonality, we can think of a behavior across 1 year, let's say, as the 1 year is a quite commonly used interval in our life. So some type of behaviors appear cyclically over this time period. Here you can see another example of the data seasonality that is around 10 to 12 years. That is sun activity. You can see there are the peaks around peaks after 12 years, and also the valleys. So this plot looks quite like a sine function, but with some small damping, let's say. But still, there is a seasonality. As you can see, there is a noticeable recurrency inside of this data.
So the data seasonality would be in organization, some kind of company meetings that happen every year, or upgrades, patching, right?
Yeah, exactly. In case not so abstract as the sun activity, if we wanted to talk about the businesses, it's like a behavior between different periods inside of a year, let's say.
Some kind of audits.
Yeah. The activity that, for example, appears one in a year in a specific moment, then can force your data to have some type of periodicity inside of it. Okay. So what we wanted to achieve is as we said, forecasting the number of incidents. But before that, we need to pretty much ask the question: is it even possible to do so? If there are any regularities, so like we said, seasonal behavior in our data, or maybe some other correlation factors inside of it, like a correlation of data with themselves, pretty much. And we're going to show you right now that indeed there are some form of regularities inside of our data. So first and foremost, there is a seasonality characteristic indeed inside of our data. I will show you on the next screen that how to split the data into the two parts, pretty much, the seasonality one and the remaining parts. But what is important is that indeed there is a strong seasonality inside of our data. As we can imagine, the seasonality is across the 1 year time period. And what is interesting is that pretty much 30% of our incidents can be explained. It's not pretty much explanation, it's more like a trend analysis, but still the 30% of our data can be predicted just by the fact of the seasonality characteristics inside of it.
They happen every year.
Yeah, there are some structural recurrence inside of our data across the time domain of a 1 year time span. And the second part of our analysis is that there is indeed the autocorrelation inside of our data. In pretty much basic words, we find out that weeks before the moment that we wanted to predict can be used to forecast the upcoming week, pretty much, and we can use to do so for past weeks, pretty much, to forecast the upcoming week, also including the week that was exactly 1 year ago, pretty much. So those numbers are not just taken from the air. We make some analysis that is called autocorrelation to find that indeed there is some strong correlation between those 5 points, pretty much, in the past, and thus this information can be used to forecast upcoming week, as inside of our model, which we are trying to forecast the closest week. But this is not important, as we can extend this, but more on that probably Axel gonna to tell you much more.
Yes, but here we can observe that we used 5 indicators.
Yep.
And adding another ones wouldn't affect the accuracy of the model, so we could just skip that.
Yep, indeed, as those 5 predictors are the most correlated with the forecasting element, so additional elements can probably will not increase the accuracy. There is a possibility that those additional data could even hurt our models.
So to forecast the upcoming week or month, we will use past month and exactly a year ago.
Yep, exactly right. More about the data analysis in the context of data seasonality. Here you can see how to maybe not do, but analyze the seasonal component inside of your data. What you need to do is pretty much for different time periods, split your data into 2 functions, the seasonal component and the remaining component. And what you wanted to achieve is to maximize the seasonality component against the remaining, the trend part. And we reach the best possible outcome for the period of a 52, which is pretty much the 1 year. So we indeed get the expected results using this seasonal decomposition analysis. So this is not like we really check different type of periods, like a month period, like a half-year period. But the great result was when we pretty much set the period to be a 1 year, and then our data was decomposed in the great form for a seasonal and remaining trend paths. Okay, so now it's time for a demo. Axel, I will pass both my voice and my laptop to you.
Thank you, Adam. Give me just a sec. I will move to our development instance. So basically, the first approach was to check what performance analytics could give us. And what is performance analytics in that case would be the KPIs and automated dashboards for showing the actual current data, and it can be presented on dashboards or widgets, or in this case, I will show you Analytics Hub and indicator. This is the form of indicator that we've created. The indicators are performance measurements taken in regular intervals to measure activities. I think that also organizational behavior, and those results in a series of indicator scores presented over time. And Analytics Hub is a good way to show that. I will navigate to this right now. And as you can see, based on our historic data, we could see here a trend, and we can observe that there are lows, significant lows in December, here and also here and also here. And that is worth mentioning because this is the period that we indeed also know for sure that incidents are, the amount of incidents are lower then. People go to holidays, it's a holiday time. So we would like to see how good performance analytics would be to forecast the future for the upcoming months. Will it be the same this year also, according to performance analytics, and we use forecast for that. Okay. So as you can see, let's check. Forecasting looks like this, and when we move to December, so performance analytics doesn't expect any lows in December. And
even though we use the seasonality.
Yes, even though we use seasonality to aggregate the average incident count, but we strongly believe that this December will also be some kind of lows during incidents, or maybe not after this webinar, but that was the main point to show it that performance analytics, even though it's based on live data, doesn't predict this low, and we wanted to see how well will predictive intelligence behave. So let's now move to predictive intelligence.
As this performance analytics trend is more like a dancing around the average line, then
based on the trend and confidence.
Yeah, exactly. It's dancing across the trend line, and it's not expecting, is not forecasting this lower value at the end of a year.
Yeah, it's all based only on average.
Yep.
So let's now move to predictive intelligence. But to use predictive intelligence, we had to prepare the data. As Adam mentioned before, we use 5 predictors. Predictor 1 is last week. Predictor 2 was 2 weeks ago. 3 and 4 is 3 and 4 weeks ago. And predictor 5 is the exact number of incidents that happened exactly a year ago. We also added week of the year just for the sake of training the solution. This is the table that we created. This is the form of record, and based on that, we trained the model, and we trained the model right here. This is our solution. I will navigate to Predictive Intelligence homepage. Where you can see the 4 main frameworks for that. Adam already told you about them. And we used regression, as you may remember. We've prepared one solution. So this is the error that we've achieved, maybe the accuracy, more on that later, but I will quickly show you how we've configured the solution, because the most time-consuming thing was to prepare the data. As you may...
It's pretty much always the case in, for the machine learning problems, that the data preparation is like 95% of the whole work, and all remaining part is like a train.
Yes, and with training, the ServiceNow is really good and quick. I think that 30 seconds was even lower than 30 seconds to train the whole model and to actually get some results. By ServiceNow, it is recommended to have at least 10,000 records. 30,000 to 300,000 is the desired one. So the models will be most accurate. What we did was we've checked the API that is available in the documentation, and because we will use only numeric outputs, we predicted that it could be the amount of records could be lower, because as you can imagine, 10,000 records, so 10,000 weeks would be like around 200 years. 200 years. So we've lowered that.
Even Spock is not so old.
Yes, even Spock. And so we've changed the properties, and based on that, as I said, we examine only numbers. So we know that regression will be good at that, even though the required amount of records is slightly lower.
Yeah, because the strictly numerical analysis is much easier to the model to train, to forecast against the model when you have like a text data. Then you need to use the natural language machinery to convert data pretty much to the meaningful, again, numbers to the model. So natural language understanding models with some texts are much more demanding, complex. So this is why we decided to reduce this number of records, and even though we got some quite good results, but more on that later.
Yeah. So basically what you see now is a regression definition form, where we can specify what to predict, and we choose table. So ML solutions are available for ITSM, HR, event management, tables, but also for other tables as well. Basically, you could put any reference string fields into those outputs and learn on them, train the model. And what you see here is also word corpus. Word corpus will be very useful when you use similarity framework for teaching the model what words often happen in your organization. Some kind of, you can add there some kind of processes name, acronyms that you use inside of organization. You specify a table here. What is important that you can put a lot of data to train the model, but the output field would be just one for each regression. What we wanted to achieve is to somehow see how many incidents are we forecasting, and that's why the output field is incidents forecast. And as I mentioned before, fields would be month ago, basically weeks from the past month, and a year ago. And what is also important that you need to add some filters to properly train the model. It can be tricky, but it doesn't have to be. Processing language is by default English. Stop words is quite interesting. We can go to this, but it's not used here exactly. But you can also use regression to process the text, and then it will become useful. Stop words are basically the words that doesn't give you any value when you search. So you can add here the list of words that should be deleted from the query when you are training the model. They are pronouns, or I think that when we will use this model for our other solution definitions, we can add some words like hello, hi, thank you, or kind regards, because they
Pretty much
even
all redundant words.
yeah, I like to see them in our incidents, of course, but I don't think they give us any value to the training of
not
model.
for our model.
Right? Yeah, exactly. So training frequency is 30 days. Once a month, we would like to retrain the model. The frequency could be changed to other options, but I think that 30 days will be quite enough for that, for our purposes. And let's now move to testing our solution, because that's the most important thing, I think, for us.
We can quite easily see on the model how to test it, how to check if the outputs are meaningful, are reasonable, using this simple form. So
yeah, so after data collection, and it is worth mentioning that we've created a custom table to prepare the data. If you would like to use the regression model for tables that already exist, the whole setup of this model would take minutes, even sometimes, and you get results and you can test the solution after a really short time.
Yeah, there's a reason why we use the custom table, but this is going to be the last part of our presentation. So
yeah, and we have some solution statistics, and this will be covered by Adam. He will talk about errors later. I would like to show you how we can test the solution right now. So Adam, let's start. What time of year will we use for our testing?
Let's say the middle of a year. So
middle of the year.
22.
It's good to say that the middle. Okay, middle of the year is 22, I guess.
Around.
Okay. It's okay.
It's like June.
Okay.
I think June.
Or May. I don't know. But it doesn't really matter, because we have to check. Okay, so last week.
So we
from
need
that
to provide
point
now
in
5
time,
different values
yes,
for the previous week, 2
yeah,
weeks ago, 3, 4 weeks ago, and also what's happened exactly 1 year ago.
So let's say that in the middle of this year, there were around 25 incidents, and in the week before that, 33, 30 month ago from this year. This week was, I don't know, 35, and exactly a year ago would be 30. This will be covered later, confidence level, when I will show you how we test it. Okay, we run some tests, and after seconds, really, we can get the point estimate that it will be around 50 incidents. But what is most important here is that with this confidence level of 95%, basically, we are sure with 95% accuracy that the incident count wouldn't be lower than 15 and wouldn't be higher than 83. But if you want to be only sure for, I don't know, let's say 75%, the range will be that different, and we will be able to check this once again. I would like to check.
Maybe just change the week for the like.
Yeah, exactly, because we want to check if the predictive intelligence will be able to predict that.
There is indeed a valley at the end of the
and
year.
there is a correlation between week of the year to our point estimate. So exact numbers of predictors, but week of the year will be 52. And as you can see, point estimate is around 14, 15. And this proves that it will be, the predictive intelligence is predicting that during end of the year, the amount of incidents will be lower. Let's check it when it's 51. It's low, is slightly higher.
Great, as expected.
As expected.
Axel, one question for you. Here you show how to forecast the upcoming week, the 1 week only. Is there any possibility to forecast more than 1 week ahead?
It is possible, but you have to keep in mind that we are predicting the next week. So if we are predicting for the upcoming month, it will be slightly less accurate, and it will be based on the prediction of next week, week after that, another prediction, week after that, another prediction. So four
so
predictions.
Pretty much different forecast will be used to forecast another point of in time. Okay.
And
okay.
that is bound to have some kind of error, the higher error.
So you need to pretty much accumulate different errors accordingly.
Yeah, but I think it can give you a little bit of perspective when planning ahead.
Okay.
As I mentioned, those solutions are here to give you information or give you more information to make decisions based on that information, not to dictate what to do exactly. So you cannot just say that after, based on the estimation, it will be 30 incidents, and you will be certain of that, because let's be clear on that, you cannot predict with 100% accuracy.
It's just impossible.
It's just impossible.
It's just another source of the knowledge for our M&D members, not like for sure information that indeed there gonna be like 52 incidents in the upcoming week. Of course, it's impossible to predict, to forecast. We are not the fortune teller, we are more like a data analysis. Okay, thanks, Axel.
Thank you.
So I will go back to the presentation right now. Whoops, I will scroll quite quickly to the last slide. Okay, so let's talk about a little bit about the results. But to compare the results, we need to explain to you how to compare different results with each other. To do that, you need to define some kind of error measure. We decided to use so-called MAPE measure. It's a pretty much the percentage error between the forecasted value and real data. It's just a sum of absolute values of differences between forecasts and expected value of the real value, divided by, again, the real observed value. It's all divided by number of observation. It's one of the most commonly used statistics. It's quite easy to understand, quite easy to imagine what it means that the model is have like a 12% of the MAPE error. It's more or less like the accuracy in each and every point. It's around 12%. So let's say that the forecast value is like 100. So pretty much plus 12 or minus 12%, it's expectation that's gonna be the actual results. Okay, we also said here that we use the SariMax model inside of a Python to forecast the future. It's a seasonal autoregressive integrated moving average exogenous model. A lot of different and tough words, but what I should say pretty much is that we more use like a SariMa model than SariMax, as we does not use the exogenous possibility of this model. So pretty much we only focused on data that's already inside of our number of incidents. We does not input to the model some external data, because the pretty much exogenous mean that we can set some additional information about those data. No, in our model we pretty much only use the information that already been inside of our data of our time series. Okay, here you can see the chart, or pretty much charts, as you can see here, starting from this point up to this space here. They are the real observation, the real amount of incidents that appear on our instance. Those three functions, pretty much, the blue, red, and green one, are corresponding with those three models. This yellow dotted one that is inside of this bluish rectangle is a real observation that pretty much appeared after end of June 20. So we have those data to compare with our forecasting three models. What is important is that this information was not passed to the our models, so models does not have the information what's gonna be on this subset, so we have used this information to pretty much examine how good our three models are. What you can see here is that the blue and the green one, so pretty much our predictive intelligence and SariMax, so this model inside of a Python, were able to predict this low valley at the end of a year. It is not as deep as this valley previously that were observed, but still it is noticeable. What is also worth to notice is that those lines here, dotted lines, are the places where the new version of a ServiceNow was released. So here you can see that there is a possibility that this release that happened 2 iterations ago caused some incidents. And again, Python expecting now that after upcoming release, there's gonna be again some higher peak in the incidents volume. The Python was pretty much the only one that noticed this potential upcoming peak, as we don't know if this peak really gonna be noticeable or not. Okay, so now I'm gonna to show you this area, but on a zoomed chart. Here you can see how those three models pretty much were able to fit to the real data. What is worth to notice is that this y-axis is starting from 0.3 up to 0.7, pretty much. So it's not like the whole range. As this is only a zoom into the small piece of our previous chart, so we can see in detail how those three models differ from our real data. They are quite close to our real data, but as again, the scale is quite low, so those differences can look quite big. They're not, as you can see after a couple of seconds when we will talk about the errors.
Scale is important here for analyzing the error.
Yep. The reference pretty much, we could show that on the scale from 0 to 1, but then you would not be able to notice these differences that indeed they are present, but still are not as big to be able to show them on the bigger set, let's say. Okay, one again chart. Now it's like a function of errors for three different models against the time domain. Here you can see pretty much that neither of the models exceed the 0.26, 27 error. So all of those models, even at the peak when the error was the most noticeable, does not exceed the 0.27 accuracy pretty much. So even though there is the high peak here, and neither of those models were able to predict this peak exactly, still the error is not as great as we could expect. Okay, so before we will show you, explain you the results, the values of our MAPE error measure, we will just tell you that there are different expectation for MAPE results. We need to tell you what it means that the error is high accurate, the model is high accurate, and the error is significantly low. What it means that the model is good, reasonable, and inaccurate. Usually, when using the MAPE measure, we can say that the model is highly accurate if the MAPE is below 10%, good between 10 and 20, reasonable, and inaccurate, respectively, as you can see here. It's always also differ for different companies for different reasons. For example, in pharmacy, the MAPE around 4-5% is high. Everything above is not pretty much treated as a good forecast model.
So forecasting with 50% errors is not reasonable.
No, it's completely unacceptable in pretty much any case. 50% is like more or less guessing than forecasting.
We can do that without predicting.
Without any models. Yeah, just using some coin or dices. Okay, and errors. Here you can see the real value of our MAPE error for 3 analyzed models: SariMax, Performance Analytics, and Predictive Intelligence. First of all, notice that neither of those models pretty much exceeds the 15% of the error, so we definitely are inside of the good forecasting bound range, even in the lower part of the good forecasting range. Python was the best one, but still there is not a big difference between the SariMax, then Performance and Predictive Intelligence. What is also worth to notice is that the Performance Analytics and Predictive Intelligence are almost indistinguishable with the real data pretty much. Here you can see that both Performance Analytics and Predictive Intelligence reach like a 14 point, I remember right, like 0.2, 0.3 accuracy. The difference between those two models were placed on like 3rd place after the meaningful place. So this is pretty much the tie between those two models.
Both solutions have more or less the same error accuracy, I should say, but predictive intelligence, once again, let's stress it, was able to predict the upcoming lower incident count.
Yeah, maybe I will just return for the moment to this chart. Here you can see that the error was counted from this point to this point, where the pretty much number of incidents is somehow averaged, is not changing much even in the previous year. What was the most important thing is that what's gonna be the error measure for our 3 models after this period here on the 4th quarter of the year. But to do so, we need to first observe those data, so pretty much wait until the end of the year and then compare those 3 models again. And then we will see is the difference between those errors is greater, less, and what is the real error after the more observation than like a 2 month pretty much. Okay, so Axel, again, the business things I'm keeping for you. So
okay, I don't think I need your laptop.
You don't need
for that.
No, okay.
So what is exactly, how can you use it in your business? Basically, as I mentioned before, this is a solution for you to gather more information and make better decisions based on that information. You have some KPIs, and I like to make these words to keep people informed. And this is basically the tool to give you more information to make better decisions. And in that case, it was based on past data, so basically to learn more accurately on the past. It can also help you planning your budget, and this is quite interesting, anticipating and managing risks. I think that the solution for regression definition would be good to analyze the change risks or estimate how the change or story will be time consuming, and it will be good to know it for your planning your budget or work capacity. And if we know that by the end of the year the incident count will be significantly lower, basically this is the time where we know that we can focus more on changes and other services. And I think that the main goal of those AI solutions will be to automate the processes and make it faster, a little bit easier, to even the work-life balance a little bit, and that would be a good thing to do.
Okay. And pretty much the last slide, what are the next steps?
So the next steps, I would like to see what are the, as we know, there are some factors that can influence the incident count. Adam mentioned upgrades. I can mention releases. Basically, we know that the more changes or the more projects go live, the higher the incident count. It's only natural that if you change something, then the incidents might occur. If you stay only out of the box, probably the incident will be only correlated with upgrades, basically, maybe, probably. And definitely maybe. And
yes,
we would like to mention those key factors and measure what's their importance for our model, basically how many people are creating incidents, how many self-services are available to customers, how many users are in the organization, because how many people are creating those incidents also affects the language used, but also directly affects the incident count. Also, I think that, as I mentioned, releases, upgrades, and holidays. Also, that's something that we've somehow observed during our regression model analysis. And basically, next step for us would be to measure the key factors. I know that probably the amount of changes implemented or projects or upgrades have the most importance or the most impact on the amount of incidents, but we would like to quantify how much exactly and compare it in different scenarios.
Or maybe if any.
Yeah, maybe something is not very significant for our model, or the accuracy wouldn't be that much higher, and we would like to just experiment a little bit and move it forward to make the model better.
So again, we have to analyze the go lives, implementations, upgrades, different, pretty much we have a list like a 12 or 15 different factors that could affect in some way the amount.
You can
of
add
incidents.
the application counts, so level of customization.
Exactly, that's an important one.
Releases, patches. I think that
so
holidays,
a lot of things to
also
analyze.
the amount of tickets that are processed by the organization. It is worth to mention that those solutions will really thrive when you have a lot of volumes of tickets, so the models can learn from them constantly, and they will get more and more accurate. And if you put some effort to correctly create stop words and words corpus for similarity definitions, the effects will be better.
Mm-hmm. Yeah, but what is worth to observe, to notice is that we analyze pretty much sum of all incidents that appear on our instances without the division on the different clients, as different clients might have like 3 or 4 incidents in total. So there is not pretty much a possibility to analyze the trend of incidents corresponding to such client. We have also the clients with much more amount of incidents, but what is the difference between the big client and the small client? How to compare those two different worlds pretty much? It's not the obvious thing. So this is why we first of all decided to analyze the aggregate amount of incident, not incidents for specific companies. Okay, pretty much it's all that we want to share with you. So I think this is the perfect time to take some questions and maybe find also some answers to them.
Yeah, I have some questions that we can ask you. I think I can take the first one that I chose.
Feel free.
Are different languages available? How hard is it to implement this functionality so system could also predict tickets in Swedish, for example? So right now we have we can look at default stop words that are presented, and I think that 8 languages is supported, but a lot of different languages I think might be incoming, so it would be easier to predict. I think that you can start learning on Swedish also, just to help the system. You would have to create Swedish stop words syllabus, and the model should basically do the same thing. And okay, the next question will be for you, Adam.
I see those Q&As, those questions pretty much. The first that I noticed, how do you get that data from the Python to be used in the ServiceNow? Is there any integration in place to automate this process? Pretty much we did this manually, so we extract the data to JSON pretty much, then inject them to the Python locally, process them, again create a data, but then in the form of the Excel spreadsheet, and then load them back again to the ServiceNow. So there is not integration right now. Probably if we would observe that the Python is definitely the best one, we would then think about the integration, as we don't then use any other form of a prediction than the Python. So we would build the integration, but right now we did this whole work manually pretty much.
Okay, I think that I can answer the question from Carol. Is there anything that could be done to improve the forecast accuracy using the same set of data, meaning I do not have more data, more correlation factors or something like that?
Exactly.
So you can test it yourself, obviously, but we found out that adding more factors doesn't really affect positively the outcome, but also you can check it yourself, and maybe there are some tweaks and changes that you can make to this solution definition, and basically it's all about the data that you prepare. The more the data is better, obviously, but I think that we can find out some correlation factors, as we mentioned. So some factors can be added to it, and we want to achieve it and measure it in the next iteration of the project.
Another question, Dominic, there are any significant differences in the number of data records required between? Pretty much the question can be reduced to the simple words. As much complicated the model is, then the more data we required to train pretty much the 3 different approaches. We use exactly the same set of data, exactly the same. But I guess that when we will try to analyze now the correlation between different events in time, we will split those data into data for different company across different domain over time. So definitely we will get then much data, even though pretty much we will use the same data, but not in this compact way as we used them before. As now we pretty much each and every record is like a 1 week that is compressed to the form of a one record. But if we wanted to analyze those data more accurate in the more with small gradients of the accuracy, we will split them again to the single days and then analyze the behaviors on the much smaller scale. So we will pretty much get more records automatically.
Adam, why choose predictive intelligence if using PA showed similar result and it's quicker to set up?
Okay, tough one, but I will try to answer this one. Indeed, the results between performance analytics and predictive intelligence are pretty much the same right now. As you remember, pretty much the performance analytics was unable to predict the behavior at the end of a year, but this is not the main reason why we decided to even invest our time to predictive intelligence. We think about predictive intelligence keeping in our mind that the next step will be to analyze some like point-wise event. Again, implementation of a big client or a new releases. Those information cannot be easily injected into the forecast of performance analytics, but we know how to inject them into our predictive intelligence model. So we decided to use predictive intelligence in a such not obvious way as because we know that the next step will be to do much more with those data. Jakub, can you make model to learn on its mistakes to make it more accurate in the future? Yes, indeed, and this is why we are using the retraining option after each 1 month, pretty much. Yes. So after 1 month, model will analyze a bigger set of data and then relearn pretty much everything that he knows already, and then he will conclude that after on the span of previous month I made some pretty much huge errors. I should be more accurate on this subset, and he will analyze them. Maybe not in this way, but he will do this more strictly using some high advanced math. But still, he will analyze the previous period, take consideration into the errors, and take them into account when building another model.
By design, this is important. The more the data, the longer it can be trained, it will be better and more accurate.
As much the more data is always better, except moments where your data has like a so-called outliner. So pretty much you can imagine that you have again time series in our case that is pretty much maybe not constant, but bounce around some values, and at 1 or 2 points you have some weird pretty much peaks or extremely valleys. So those elements are called outliers that usually should be removed from your data to give your model more consistent information pretty much.
Okay.
So usually more is better, but not always.
Okay, I think that our time is almost up.
I have so much questions.
So much questions. Okay. We will answer them all on email or somehow we will answer your questions, I promise. And thank you for your attention. And
thank you so much.
I hope to see you again.
I hope that this is not the last time when we can meet with you and show our results. I hope that after maybe in the upcoming year we can meet again and analyze what are the errors, the differences with those 3 models, or maybe even another iteration of our models against the data that appeared during upcoming month. So that's all. Thank you so much
very much
for your attention.
Bye.
See ya.